Welcome to this session. So first I have a good news and a bad news. So the bad news is that it's a 35 minutes long session, which is really short. And the good news is that because of that, I've decided to skip all my demos. So basically, we will not suffer from any Beamer issue. So before we start, some logistics. So my name is David Delabassée. I work at Oracle. So I spent like 7 or 8 years at Oracle on server-side Java. Prior to that, I spent 10 years at Sun working on Java stuff. And prior to that, I spent 4 years in a telco working on Java stuff. So basically, you can see by looking at the evolution of my haircut style through the years that I've been in the Java space since quite some times. So this was me a few months ago at JFocus, a conference in Sweden, and someone in the audience said that it's not a real conference unless you read Oracle's safe harbor statement at least once. So please enjoy. Having said that, what I will discuss today is Java 8. Java 8 is finalized, so there's nothing which is forward-looking in my presentation. So in the next 34 minutes, I will basically give you an overview of Java 8. And one of the important things about Java 8 is that E4J, so the E4J 1.0, whatever it's called, the bits will have to be compatible with Java 8. So basically, we'll spend this session to talk about what's in Java 8, but also basically what will be at the beginning in E4J. So today we'll basically give you an overview and update on some of the API that has been updated in the platform. The first API that I will discuss is jax-rs. So in jax-rs 2, Java 7, we have added a client-side API. So jax-rs was basically a server-side framework that you can use to easily expose REST endpoint. In jax-rs 2, we have added the capability to easily consume those REST endpoints. So you see basically how the API works. So we have this notion of a client-side container. So you get an instance of a client container. From there, you build a web target, so where on the network is your remote endpoint. From the web target, you construct the request. And finally, at some point in time, you will invoke the request to hopefully get some result from the remote endpoint. The thing that is key here, so you see that I have the get method, so it's an HTTP get method, but this is a blocking call. So basically, my code will block until the remote endpoint has sent the result back. The good news is that in jax-rs 2, we have also added synchronous capability to the client-side API. So it works like this. So this is basically the same request, but this time I'm using this async method to basically tell to my client-side container that this is an asynchronous request. And you can look at the return type. What we have in return is a future object of the response type. So that basically means that at some point in time, we will be able to access the response that will be sent by the remote endpoint. Now, given that we're going over the network, if it takes 5 seconds to get your result, it will take 5 seconds to access the result using the feature object. So as soon as you do a get on the feature object, you will have another blocking call. So we have not really solved the issue of the blocking call by introducing these asynchronous capabilities. Also, something that you need to make sure is that you need to make sure that you have some timeouts set to make sure that your code doesn't block for too long if it has to block. Now, what we also did in jax-rs 2, we have added an invocation callback facility that allows you to work around that issue. So the way it works, this is the same request. So I'm using the async invoker to specify that this is an asynchronous request. But this time, I'm passing an instance of an invocation callback, which is a callback that's an interface that needs to have 2 methods. One is the completed method, so that's the callback that will be invoked when the remote endpoint will send the result. And the other one is the fail method that will consume some throwable type if something goes wrong. So let's put that into perspective with this very simple microservices-like scenario. So we have one main services, the travel agency services, that will consume 4 backend services. The idea of the scenario is the following. So we have a user that comes in. The travel agency services would like to propose some destination for that user. So it will have first to go to the customer services to get the history of that users. Then based on that, it will invoke the destination services to get some potential destination to suggest. And for all the destination that he is about to suggest, the travel agency services needs to invoke the weather and the quoting services to include some additional information to the suggestion that it will do to the end users. So we know that we want to go async for that. Why? Because there are some dependency between some services, but there are also invocation that can be done in parallel. For example, once you have the destination, you can invoke in parallel the quoting services and the weather services. So let's try to implement that using the async API of jax-rs 2, but let's simplify a little bit that example. We just have to, let's pretend we only have 2 services. So the first request that we do, we want to get the destination, some destination to suggest. This is an async request, so we are using the async invoker. So that means that we need to pass it an invocation callback. That invocation callback has to call back the completed callback. So basically, when we have all the potential destination that we're about to suggest, we basically go over all the destination, and for each destination, we do another request invocation for that given destination in an async fashion. So that means that we need to specify the invocation callback for that type, for that invocation. That invocation has 2 callback, the completed. So basically, once we have the forecast for that destination, we put it in a map. And obviously, we also have to deal with the error at different level. So basically, I guess that you see where I want to go to. This is basically the callback hell. So that code is very difficult to write, to debug, and maintain. And that's also why I had to simplify and go for 4 services to 2 services, just to try to make it fit on 2 slides. The good news is that in jax-rs 2.1, in Java 8, E4J1.0, if you will, we are solving that with the addition of a new invoker. So we have in jax-rs 2.1 a reactive asynchronous invoker. That's the Rx method that we have there. And if you look at the return type that we get, it's a completion stage type. So we have a completion stage of the response type. So if you know Java SE8, the completion stage API of Java SE8 is this API that defines this notion of stage. A stage being an asynchronous computation, an asynchronous task that can trigger the execution of other stage. So basically, with that API, with the completion stage, we have the facility that allows us to define a pipeline invocation in an async fashion. So we can trigger, we first do a request, then once we have the result, we trigger the execution of another request in an async fashion. And obviously, at the end, we combine all the results together. So in jax-rs 2.1, we can now do this. So we have a first request. It's an async reactive request. So we have a completion stage of JSON object in this case that we can chain to another request. So I define my 2 requests, and then it's just a matter of using the completion stage API of SE8. So I have my first completion stage. Once I have the result, so that's the then compose, I'm invoking this function. And if you look at that function, it's basically a function that gets a JSON object and that return another completion stage. So basically, once I have the result of the first request, I trigger the second request. And obviously, I have to do something with the result. So in this case, I'm just passing it a simple consumer that will display the result of the second request, which is in itself based on the first request. So in jax-rs 2.1, we are adding this new invoker. And clearly, if you have any scenario that involved REST request invocation, and if you have dependency between those request invocation, you'd better use that API. You can do that using the async API of jax-rs 2, but clearly the code is very difficult to write. And the good news is that with this new invoker, we are using the completion stage API of Java SE8. Now, we also acknowledge that there are other reactive API in the market. So this jax-rs 2.1 specification has been designed in a way so that it's open to other solutions. So it's mandatory to support the completion stage API of SE8. But if a jax-rs provider wants to support other solutions, it's perfectly possible. In Jersey, for example, we are supporting the Guava listenable feature, and we are also supporting RxJava and RxJava 2. So that's something which is part of jax-rs 2.1 Java 8 today. Something else which is part of jax-rs 2.1 is support for SSE, server-sent event. So SSE is basically a very simple mechanism that is used to push from the server side payload to the backend side. The nice thing about SSE is that it's widely used. It's quite firewall friendly, so it can go easily through firewall. And it's basically supported by all the modern browsers. And if you have a browser, that also means that you have a JavaScript API that you can use on the client side to trigger something when you receive some payload. So in jax-rs 2.1, we are adding support for SSE on the server-side API, but also on the client-side API. So jax-rs 2.1 defines this super interface, SSE event, which is basically just an SSE event. And that interface is extended on the two sides of the connection, on the server side and on the client side. On the server side, it's called an outbound SSE event, and on the client side, it's called inbound SSE event. Something to keep in mind, SSE is one way only. So the client establishes a connection, and then the server has a channel to push notification to the client. So you will always create event on the server side, and on the client side, you will just consume event. You will never create an event on the client side. So we also have this SSE event thing object, which basically represents a connection, an SSE connection. This is the server-side view of the connection. So how it works? So we try to reuse as much as we can from the jax-rs standard API. So this is the jax-rs resource method. We are injecting two objects here, SSE event thing, so the actual connection object, and an SSE context object, which is not mandatory, but it's a bit convenient to use that one. Then we just reuse the standard jax-rs annotation. And all it takes from a server endpoint to push payload to a connected client is basically to take the connection object and invoke the send method on it and pass it some event type. So that's why I'm using the SSE object which has been injected. So it's basically a shortcut to easily create a SSE event. You will do that multiple times, and you will see at some point in time you will have to close the SSE connection. So this is the server-side view. On the client side, we are reusing the same concept. So we are still using the jax-rs client-side container. So we have a client container. From there, we set a web target. So that's basically the remote location of our server SSE endpoint. Then we create an SSE event source, which is the connection object. But this time, this is the client-side view of the connection object. So the event source is set on the target. We can configure a few things like the reconnect interval. And then we need to build that object. So the only thing that we do here is creating the object. We're not establishing the connection yet. Then we have to register a few callbacks. The one that you want to make sure to register is the callback that will consume inbound SSE event type. So basically, when there is some payload coming in, that callback will be automatically invoked. In this case, I'm just printing what's there. But for example, you can also register a callback that will consume a throwable type. If something goes wrong, that callback will be invoked. And then what you need to make sure is to invoke the open method on the connection itself. So that's basically where you tell your jax-rs client container that you want him to establish the connection, to register all the callback, and so on. So basically do all the heavy lifting for you. And from that point on, at any time some payload will be pushed over that SSE channel, your callback will be automatically invoked. So these reactive invoker and SSE are the two new large addition of jax-rs 2.1, but there are other steps that we are doing in jax-rs 2.1. I don't really have the time to go over them today. So I will move on to the JSON support that we have in Java 8. So basically in Java 8, we have improved the existing JSON API. So we've moved from JSON P 1.0 to JSON P 1.1, and we have added a new binding API. So the JSON API, basically the main aspect of that update was to cope with some new standards that are emerging in the JSON space. One of them is a JSON pointer. The name is very obvious. A pointer is basically a syntax that is used to define a location within a JSON document. So we have an example here. So if you look at /1/venue, so /1 basically means that we want the object in that array at index 1, so basically the second object. And within that object, we want the key value that has the venue key. So basically, we're talking about that guy there. Now, what I've done here using the JSON API, I've just defined a pointer. Now I need to do something with it. So we have a few operations that are provided by the JSON API, like getValue. So if I do that, what I would get in return would be Hilton. I would get that value in return. Another method that we have is the replace operation. So given that it's a replace operation, we need to specify what the new value will be. And this time, we want to replace that Hilton value with Moscone West. Now, something important, the JSON API is an immutable API. So that means that what we get in return is a new object. We are not touching the original object. Then we have a few other operations like add, removed, contains value. So basically some CRUD operation and some testing operation. So another standard that is part of the JSON API is JSON patch. So basically a patch is a JSON document that contains one or more operations that will be used to modify another JSON document. So on the left side, we have a patch. It has two operations. The first one is a replace operation, and the second one is a add operation. We are using the JSON pointer syntax. So let's pretend that we want to apply that patch to that target. So the first operation is a replace operation. So we want to replace the venue Hilton with Moscone West. It works. The patch is atomic, so that means that if one of the operations fails, the complete patch is aborted, but this time it works. So we can move on to the next operation, which is an add operation. And here we want to add a new key value, which is previous venue, and with the value Hilton. So that would be the end result. So that's the JSON side of the AP of JSON patch. Now let's look at the Java side of JSON patch. So we have two JSON documents. One is the JSON document that we want to modify, and the other one is the patch. So a JSON patch is in itself a JSON document. So we have the JSON document. To create a patch from it, we just need to invoke this JSON create patch and pass it the patch itself. Then we just need to apply the patch to a JSON document. Now, something which is quite handy in JSON P11, we have this builder-based API that you can use to easily construct patch, basically. And obviously, once you have your patch defined, you need to invoke the build method to construct the patch itself, and you need to apply it to modify a target. So another standard that is part of JSON P11 is merge patch. So it's basically a different way of modifying a JSON document. Something which is quite handy is that we have patch and merge patch, which is used to modify a JSON document, but we basically have the reverse operation, so we can get a diff between two JSON documents. And then there are other stuff that are being done in JSON P11, like the support for specific JSON P collectors, for example. So moving on the JSON front, we are adding a new API. It's a binding API that you can use to marshal and unmarshal Java object to and from JSON document. It's a standard API that is sitting on different JSON binding solutions, like Eclipse json, which is the reference implementation, is one of the solutions. It's basically the default one. So the specification defines the common and default behavior, and obviously you as a developer have the ability to override that default behavior. So it supports basic types, some specific JDK types like URI, URL, optional, date. It supports class with inheritance, collection, arrays, and so on and so on. This is an example. So I have a very basic Java object, which is a list of conference. So if I want to convert that to a JSON object, I first need to have a JSONB object that I get using this JSON builder create invocation. I don't specify anything, so basically I will get the reference implementation, Eclipse JSON. And then I use the toJSON on that object. I pass it my Java object, and what I get in return is a string that would contain the JSON representation of that Java object. Obviously, we're using string, but we also support output stream, writer, and so on. We have the reverse operation, so if we want to go from there to a Java object, we still need a JSONB object, but this time we're using the from.json method. We pass it our string representation that contain the JSON payload, and we pass it the type that we expect to get back, and what we would get would be an event Java object that would contain those details. So it's convention over configuration. So if you don't specify anything, for example, the field name would be used to infer the key name, the name of the key that needs to be used. So if I don't specify anything, for example, my key would be event name. Obviously, I have the ability to override and customize that using, for example, some of the annotations that are introduced in JSONB, like JSONB property. So in this case, I want the key name to be conference instead of event name. And there are many ways to configure how JSONB would marshal and unmarshal objects. You can specify and use different naming strategy. You can work and tweak the order in which the property would be laid out. What should we do if we have binary? How should we handle them? Maybe there are some properties that you want to ignore. What should we do if we are null? By default, they will be ignored, but in some cases, it might be useful to carry them over, and so on and so on. So the customization is done either using annotation or using this JSON-B config object. So basically, you create a configuration object that you pass when you are creating this JSON-B object itself. And something which is quite important is that the JSON-B API is just a standard API that sits on top of existing solution, like Eclipse JSON. So you, as a developer, have the ability to switch between different compatible solutions. The way you do that, you just specify when you are creating your JSON-B object, which implementation you want to use. I will skip this one, but just keep in mind there are many ways to configure JSON-B, and if that's not enough, you can go under the hood using either adapters or even below that using serializer and deserializer. And Dimitri has a specific session on Eclipse JSON later this week. So if you're interested, I encourage you to check that one. Now let's talk about what we have done in Java 8 on the web front. I think that everybody agrees that the main update is Servlet 4. Now, in Servlet 4, we did a bunch of things, but clearly the main thing about Servlet 4 is to add support to the platform for HTTP2. So we're talking about server-side HTTP2 support. I don't have the time to go over HTTP2, but if you just have to remember two things about HTTP2, so first, the goal of HTTP2 is basically about reducing the latency of web application. How this is done? By using a binary-based protocol. HTTP 1.1 is a text-based protocol. HTTP2 is a binary-based protocol. In HTTP 1.1, if you need to fetch multiple resources, your client will have to basically do multiple requests. So you will have to open multiple TCP sockets, which is a very expensive operation on the client side, but also on the server side. In HTTP2, we have this notion of streams, which is just a logical connection. So the client will open one physical connection, but it's a binary-based connection, and then the client can issue multiple logical connections over that physical connection. So it's way more efficient than HTTP 1.1. And more importantly, HTTP2 preserves all the HTTP semantics that we have been using for years. So we still have this notion of request response, this notion of headers, cookies, and so on and so on. So for you developers, nothing is changing with HTTP2. Nothing's changed unless you want to use one of, well, a new feature which is part of HTTP2, which is called server push. So server push is basically about giving the ability for a server to proactively push resources to the client. So with HTTP 1.1, the client do a request, the server will answer with one response. With HTTP 2, the client do a request, and the server has the ability to answer with one response or multiple response. So this is something which could be useful, for example, if the server wants to proactively put stuff in the client cache before the client even knows that it will need those stuff. So if you want to do that, you will have to update your code. So it's a very simple API. There should always be an incoming request. So it's not like SSC where the server can push in a completely async fashion stuff to the client. There is an incoming request and the server can decide to answer with more than just one response. So we have this incoming request. We need to have a push builder object for that given request. Once we have that, we have the ability to configure the response. So we can define some headers to the response that will be used to push those resources to the client. And obviously, we have to specify what the path of the resources, so that's basically the resources that we want to push from the server to the client side. And then we just need to invoke the push method. So that's basically where we say to our servlet container that, okay, I would like you to push these resources to the client. Now, there is no way to know if the resources will be effectively pushed. So for many reasons, it might not be pushed, or it might happen that the resources is already on the client side. In that case, the client will just decline the resources. So if you want to use that facility, you will have to update your code. If not, you take your existing servlet application, you deploy it on top of an HTTP4 servlet container, and out of the box, it will support HTTP2. On the web front, we are also updating GSF 2.3, so a lot of goodies that are nice if you are using GSF today. So for example, GSF will automatically try to push the resources for you. So you just take a GSF 2.3 application and you deploy it on top of a servlet 4 container, and automatically the server will try to push the resources for you. So let's move on and talk about two specifications which have been updated, and those two specifications are handled by our friends at Red Hat. The first one is CDI, context and dependency injection. So clearly, CDI is really the backbone technology of the Java EE platform. Now, if you look at CDI 2, a lot of the updates that have been done in CDI 2 are not that relevant for us Java EE developers. Why? Because one of the goals of CDI 2 is to boost the adoption of CDI outside of the Java ecosystem. So for example, now the specification is more modular, so we have CDI core. Based on that, we have CDI for Java SE, and based on that, we have CDI for Java EE. That's what we, Java EE, are consuming. CDI 2 also defines how you can bootstrap a container in a standard way. Again, it's something that is not really important for us because that's something which the application server is doing for us since years. Nevertheless, there are stuff which are quite useful for us Java developers in CDI 2. So in CDI 1.0, we have this very nice producer patterns event mechanism. So we produce an event, and then we have at least one observer that will be triggered whenever the event is produced. In CDI 1.0, we can have more than one observer. The thing is that we don't know in which order they will be invoked. In CDI 2, this is being solved. We have the ability to basically set the ordering of the different observers that we have for the same event type. Something else, we now have asynchronous event. So if you look at the previous example, the observer were invoked in the producing thread. So basically, everything was done in a single thread. In CDI 2, we now have async event. It works the same way, but this time we are using the fire async method. And you see that the return type here is a completion stage object. So basically an object that will allow us to see what happened at some point in time or deal with any potential error that might arise in our consumer. On the consuming side, we just have to use this new @observe_async annotation to specify that this is an asynchronous observer. And automatically, that observer will be invoked in a different thread. Bin validation is being updated in Java SE8. We are adding, Red Hat is adding support for new constraint validation that were part of Hibernate Validator. And one of the things about bin validation 2 is basically try to embrace Java SE8. So for example, now you can do these kind of things using bin validation too, because in AC8 you have the ability to set annotation on parameterized type. So if you look at the first example, we have a list of emails, and basically what we want to do, we want to apply the constraint validation on all the elements of that list, not on the list object itself. Bin validation support validation using the Java AC8 date and time API. It supports the optional type which has been added in AC8. It also supports repeatable annotation. Now, the last API that I will quickly discuss is this new security API. So it's a new API that is added to the platform. Now, the fact that we're adding a security API doesn't mean that Java EE was not secure before. The goal of that API is really to simplify how you can apply security concern in your Java EE application. So one of the things that is being defined is this notion of an identity store. So basically an identity store is basically a storage for your user-related details. And it's the identity store that will perform the actual validation. But at no point in time, the identity store will interact directly with the end users. So the specification is defining two. So we have an LDAP and a database identity store. And to use them, it's just a matter of using the annotation and configure where your users are stored. So this is, for example, the database one. So if we put that into a practice, so let's pretend that we have a servlet that we want to secure, and we only want to allow user in role foo to access that servlet application. So it's basically all it takes. So we set the security constraint and we inject an identity store, and everything will be handled for us by the application server. We have the ability to write our custom identity store. So you just need to implement that identity store interface, and you have to implement at least the validate method. And then something else which is part of that API is the introduction of a new authentication mechanism. So it's basically an abstraction on top of the jaspik API, which was very difficult to use. So it's basically a simple way to use jaspik just for web application. So the spec is defining a few of those, like basic authentication, form, and custom forms. And obviously, you as a developer have the ability to write your own custom authentication mechanism. Again, if you want to implement your own, I think that you only have to implement the validate request method. So how it works, again, the same way. So we have a servlet that we want to secure. So we are using the servlet security annotation that is part of the Java platform since quite some times. Only user info are allowed to come in. So I also need to include in my web app an implementation of my authentication mechanism. And I need to make sure that I implement the validate request. And what I can also do, I can inject in that my own identity store. So that was a very quick overview of what we have today in Java EE8. So Java EE8 is basically about modernization and simplification of the platform. Just keep in mind that Java EE8 is basically what EE4J 1.0 will be about. So Java EE8 is finalized. It has been released 1 month ago. GlassFish 5, which is an open source reference implementation, is also available today. So you can obviously use all those APIs. In fact, you could use them before, because we have been developing Java EE basically on GitHub. So you could see what is being done even before it was finalized. And obviously, we have exciting stuff ahead of us. That's EE4J. So given that we're running out of time, I will just encourage you to come to the panel that we have at 7, where we will discuss all of that. So basically, what EE4J is about and what we plan to do, and obviously, well, it's a panel, so you will have to bring your questions. And not only that, we also have a buff tonight, if we don't have enough time to discuss that. And then 2 other Java EE related session that you might want to attend. So with that, thank you.